My name is Ben Owens. In this video, we're going to look at functions and the special rule that must be followed in order for a relation to be considered a function. The special rule that we have in order for something to be called a function is this. In order for a relation to be a function, each item in the domain, that is each input, may only go to one item in the range. So I have here several examples where we can look and see whether or not these are functions. So in this first example, we see that the number 2 goes to 4, the number 3 goes to 8, and the number 5 goes to 7. In this case, the number 2, or each number in the domain, does just go to one number in the range. And so that we would say that yes, this is a function. An example of a problem like this that would not be a function might look like this. Suppose we had a number here, 3, in the domain that gets mapped to 2 different places, 5 and 7. This would not be a function. So anytime on a conceptual mapping that you have something that goes to 2 places is no longer considered a function. In example 2, we have our x values in the domain and our y values in the range. Notice that 4 goes to 3, which is okay, and 8 goes to 7, which is okay, but here 4 is also mapped to -1. In this case, this would be not a function. The reason is that this item, 4, in the domain, is being mapped to 2 places. Now, imagine that this function that we have here, or this relation actually, was called h. If we were to say h of 4, that is, remember using function notation, this is asking if you input the number 4, what is the output? If we wrote this, there would be a little bit of confusion as to what the output needed to be, right? Is this 3? Is it -1? We don't really know. That's why this is not considered a function. Functions don't have this problem. In the third example, here we have 3 ordered pairs. In this case, 2 goes to 1, 3 goes to 7, and 4 goes to 7. Now, is this a function? In this case, the answer would be yes. This is a function. Now, you might be wondering, well, what about 7, right? It's listed twice. Here's the deal. When we're looking to see whether something is a function, it only matters that the domain is mapped to something different. That is, 3 is mapped to 7 and 4 is mapped to 7 is okay, right? It doesn't matter that we have 2 7s in the range. If we think about a conceptual mapping of this, we might have something like this, 2, 3, and 4. And then here are the numbers we would have 1 and 7. In this case, 2 gets mapped to 1, 3 goes to 7, and 4 goes to 7. Notice that 3 is only going to one place, and 4 is only going to one place. They just happen to be the same. That is okay. So when you have this type of situation, this is considered a function. Now, in the final example, if you watch the first video on functions, we were talking about a function that gives us, or a relation that has a U.S. city and an NFL football team. So if you input Dallas in here, this of course would go over and be mapped to the Cowboys. So the question is this a function? Well, at first it seems like so. But really the question is this. Is there a U.S. city that is mapped to 2 different places? Or in this case, is there a U.S. city that has 2 different NFL football teams? Well, it happens that there is one. New York is what? Well, on the one hand, there's the Giants, but on the other hand, there's also the Jets. So this football example, because of this, is actually not a function. I hope these examples help to illustrate this special rule that has to be followed in order for something to be considered a function. Thanks for watching.